breadboard. Instead, I just have this hacky little number. So it's essentially, it's a potentiometer, which you remember this is just like a resistor, just a variable resistor, and then I have a capacitor here. So when I connect this signal generator up, here are my leads. Notice this is connected to the part that says output, but inconveniently enough, it just so happens to have the exact same connection type to sync. So if it's connected here, you won't see anything, right? Because this is not generating an output. So double check that. Somebody might have accidentally messed with that. Okay, so for a low pass filter, that is when I have my resistor tied to the high side. So connect that to the high side, and then the leg of the capacitor is connected to the low side, and then they share one node in common. Okay, cool. So I'm going to turn on my signal generator here. Right now it's at 1 kilohertz. I think that the maximum resistance of this, I'm pretty sure, is 1K, and I think that this capacitor was something like 0.1 microfarad or something like that. Whatever, it came out to 100 microseconds as the time constant. Okay, so as a result, it was something like 1.66 repeating kilohertz would be my would be greater than 5 tau. I think this was like 6 to 8 tau, somewhere in there. Okay, for my amplitude, does anybody remember what's the quirk with signal generators when it says 10 volts peak to peak or something like that? So right now it says 100. So let me go to 5. Why 5 if I want 10 volts peak to peak? Anybody remember the quirk?
Because it goes negative.
What's that?
Because it goes like down.
No. Good guess though. Anybody else know? This is a weird nuance of these machines. So the reason is because the people who constructed these are expecting you, the engineer, to be working with something on the order of a 50 ohm load. There's a 50 ohm resistor in series with this output. However, this is much bigger than 50 ohms, right? So most of the voltage drop is happening across here. If we were working with a 50 ohm load, this is saying that that's going to be basically the from plus to minus here that's provided, that's the voltage being provided. But because almost all of the voltage drop is happening across this resistor, it's actually going to be 10 volts, right? Because the internal supply is going to give you twice whatever's on here, because it assumes it's going to be cut in half by your 50 ohm load. But you're going to have a much greater load than 50 ohms. Okay? So the frequency sets that, the amplitude is set to that. Okay, so for the oscilloscope, I would suggest that you use one of your oscilloscope probes for the input signal and the other one for the output signal. This came unclipped, 1 sec. Okay, so for this, if I want to connect to the input signal, where does the clip go? Where's the alligator clip?
Oh.
Yeah, that goes to ground. Yeah, sorry, clip was ambiguous because they're both clips. So, oh no, speaking of clips, this one's being very finicky right now. Yeah, okay, hopefully that's barely hanging on. I might need to reattach that. You know, I'll just attach that at the end. Okay, so you were saying the top left node for yeah. So that is gonna go to that side. Cool. Okay, all right, so that's my input, and then for my output, actually I can just show that one first. So now, turn this guy on. So input is gonna be my yellow channel, and then output's gonna be my green channel. I'm gonna wait till that boots up to do the thing. Okay, cool. So it looks like we got something is happening. We don't know what yet. Okay, so we've got our yellow channel, something is happening. Our green channel, nothing is happening. So I'm gonna kill this one for now. Just press the number 2 until it goes away. Okay, so I've got this channel right here. It looks kind of good, but kind of looks sort of bad. So let me see what's up with my trigger. Does anybody remember, what does a trigger do? This triggers when to start sampling so that it looks like we had a standing wave. Okay, so it's actually discernible. If I move the trigger outside of this, you can see that it's like, doesn't know what it's doing, okay? Because it's expecting for it to reach a certain output level. So let me bring this down to where it's down here. I don't know why it's being so noisy right now, but maybe we'll figure that out in a second. Condense time. Oh, right, because I don't have ground connected. So it's trying its best. Uh-oh. Let me see if I can fix this. That's better. Okay, so let me turn this one off. Back on again. It still doesn't look great. Oh, and you can see that the amplitude has been reset, so we need to set that back to 5. In order to get 10 volts peak to peak out, which we'll verify in just a sec. Yeah, I'm not too sure why it's being so squirrely right now. Might be because these probes, these might have been the ones that were acting funky last time. Let's see if these ones are any better. Okay, and no, it still looks the same. Whatever. Maybe if oh, there we go. You know what it was? It was being close to something over here. Or was it? I don't know. But it looks pretty now, so we'll leave it. Cool, okay. So if I look at this, it says 2 volts per division. Let me condense it down to where it's a little bit easier to digest. 5 volts per division. Peak to peak, now you can see it's 10 volts. All right, so that's what I was talking about with the quirk here. It says 5 volts peak to peak, but it's really 10 volts. Okay. We're doing a square wave in this lab. So here's my square wave. Not a super pretty square wave. I think that that's the reason that these probes were switched out. So let me see if we have a better looking signal with the other ones now. Because I think that's why I took them off initially. I think that was just an issue with the signal generator, not the probes themselves. Yeah, that looks a little bit better. Still a little bit noisy. Okay. Maybe if this isn't overlapping with itself, maybe it's a bit better. You don't want it being like a big inductor, but oh well, it's gonna be a big inductor for now. Okay, so here's my square wave. If I want to look at the input signal, where should I put these probes? So where does this clip go? Really quick, loud, or really loud, so that I know everybody knows. Okay, ground, not really quick, sorry. So ground, cool. And then where is my measurement probe gonna go? Top right before the capacitor. So we're measuring the voltage across the capacitor at this point. Cool. I still don't see green on here, so what do I need to do? Turn it on. Press 2. That turns it on. And you see we get this curve right here. Okay, really quick, I'm going to talk about DC coupling for a second. So if I center both of these, remember that centering in general, a lot of functions here, you just push the thing to center it. Like to center the trigger, you just push this button in. That centers your trigger on whichever trace you're triggering on. In this case, we're triggering on trigger type. We're triggering on source 1. Okay. Doesn't really matter because we have both probes plugged in. Okay, and then let's say that I'm going to center both of these in the middle, okay? So on my oscilloscope, each one of these lines has a value, right? So in the middle, we have 0. Moving up, we have positive whatever my divisions is, so +5, +10, +15. Moving downwards, it goes negative. But you'll notice here that when I go to offset, I'm going to change this offset. So now the same quirk applies. I want to go 0 to 10 volts rather than -5 to 5, which is essentially what this thing is doing right now. So what would my offset voltage be according to the quirk? How much do I need to scoot my signal by? 5 in actuality, right? But 5 volts in the real world is 2.5 volts on this because this is kind of silly because it's like no half. So 2.5, yeah. So 1, 2, and then over here we have 0.5. Cool. So now you'll notice that the green wave has shifted up, but the yellow wave hasn't. So why might that be? Kind of hard to know. This is basically, I would be very surprised if anybody knew at this point, but it has to do with the coupling on this instrument. So coupling basically means when I read the voltages from these probes, am I going to post-process the signal or not? Am I just going to show what it is? So if it's 0 to 10, I'll just say it's 0 to 10. Or I can have it in AC coupling, which basically means whatever DC offset there is, so if it's scooted at all, like 0 to 10 is, I'm going to shift it down to make the quiescent point just halfway between where it's bouncing between. Okay? So then it automatically scoots it down. So you can see that in the green mode, we have we go back. So number 2, you can see that the coupling is on DC. And you can see that we can go from 0 here up to 10. And there's this little curve, right? That's the capacitor doing its thing, which we'll talk about in a second. But for the yellow curve, you can see it still looks like it's going from -5 to 5. If I press the 1 here, you see that the coupling here says AC. So it's artificially set that quiescent point to be halfway up our signal, which is the reason that it's going -5 to 5, right? So if I change this to DC, what should happen? It should go up, yeah, exactly. So we change that, and it goes up, and then our signal freaks out. Why does it freak out? I heard it kind of muttered. Yeah, the trigger. So let's look at where the trigger is right now. I don't even see it. Oh, there it is. So this little guy right here, and this is triggering off of, which channel did it say? Let me click this. So I clicked trigger, and now I click trigger type. So it says source 1. So it's looking at that yellow curve saying, where do you want me to start recording? So I need to go up to the point where it's up to halfway on that curve somewhere. Or, just up inside of that curve. So now it's inside of it, so now we're keeping track. As soon as I go outside of it, it freaks out again. Okay, so does everybody see that little cursor there?
Yeah.
Okay, so if I click this, it's just gonna find the 50% point of my signal and then go to it, right? Which at this point, see, it doesn't go to 0. It goes to 50% of whatever signal I have. And right now it's on DC coupling. Again, if I changed both to AC coupling, what would happen to those? They go down. Where do they go down to? Or describe it however you can. Yeah, where's the middle point?
It goes like 5 to -5.
Yeah, exactly. That's exactly right. If I change this back now, so I'll get rid of my DC offset. So let me just bring this down to like 0. See what's happening on the curve? This is 0, right? So it's hovering about the 0 point right now. The trigger again has lost it, so we're gonna recenter that. Cool. So that's with no DC offset. When I change the DC offset, it scoots it up, right? It's basically my signal plus some static voltage value, which is that's what DC offset or DC bias is. Okay, cool. Any questions about this stuff so far? A lot of material. This is why we're filming this, is because it's a lot to digest. Okay. Awesome. Okay, so when I play around with this little resistor and I do something like that, everybody see what's happening? Ignore what's happening with the yellow curve. The yellow curve is a little squirrely. So when I stretch this out, what is happening? What's happening to my time constant? Is it going up or down? How many vote up? How many vote down? Okay, so I'll do it again. Ready? Uh-oh. Oh God. Oh no. Oh, it's so loose. There we go. This should be a little bit tighter. Okay, so here to here, here to here, time constant going up or down? It's going up. Time up means longer. It's taking a longer time for it to charge up, right? If I get beyond a certain point, oh, it looks like I can't because I set my frequency well. Right, so if I go to my frequency, we're at 1 kilohertz right now. If I try to go faster, you see how it doesn't have time to get fully charged and gets cut off. So that in the lab report, when it says to choose a frequency which is sufficient for whatever your tau is, it means choose one such that you give it enough time to fully charge to sort of taper off to what it's trying to reach. So like 1.6 I think is what I wanted to do, but it looks like we were a little off in our calculation. So right now I'm at 800 hertz. That's, fine. Okay. Any questions about that? Cool. So right now we actually don't know what tau of this is, right? Because this resistor right here, well, I could scoot all the way to the side. Now I know what it is, but then when I change it, I don't know, what my tau is going to be. You're not using a potentiometer for this. You're going to use a normal resistor. So you'll have a fixed value that you'll be able to investigate. So now you're going to measure, or you're going to log this wave in 2 ways. First of all, you need both the ascending and descending curves. So when it turns on and when it turns off, you're going to need to calculate what the expected voltages for those points are for both the high pass, or for the low pass circuit and the high pass circuit. Okay. Now what you're going to do is, in order to grab this, what we're seeing right here, I'm going to hit stop. So it's just going to stop whatever the last measurement was. Now it doesn't matter what I do to this circuit, it will not change because it's just a picture of what we last saw. And I'm going to take a USB, just a little flash drive, plug it in there, click save, recall. I'm going to go to save, format, CSV, save to, in this case it says none because there's no USB connected, right? And then once I chose something, this little press to save would pop up, and then you press that. And that saves the CSV data for your channels right here, okay? Let me run this again. The other way that you're gonna measure this stuff, and this is the part that might be a little confusing, but hopefully we demystify, is you're gonna use these things called cursors. Okay, so right now we have a bunch of cursors. Let me see if I can turn them off. Okay, so the cursors are now gone. And let me turn the cursors off, or on again. Okay, so here are my cursors, and I have this little selection right here for X1, X2, Y1, and Y2. X1, X2 linked and Y1, Y2 linked don't matter. It means it's just moving both of them at once. So for X1, X2, that refers to what is the X-axis on an oscilloscope? Time, right? So I've selected X1, so you can see that this guy right here is scooting around. This is my X1. And if you looked on here, you can see this is currently a negative value, right? That's because the center of the oscilloscope screen is 0 for both axes, right? So now we're pretty much at 0? Where's 0? Give me 0. I guess 0 is, probably because this isn't centered. Let me push that to 0. Yep. Okay, so this is 0. Cool. So what we could do is we could measure, we could find, calculate tau. In our case, we said it was something like 100 microseconds. So tau would be right here, okay? And then I would take my other cursor. Oh, sorry circuit. Take my, so what is the Y axis on the oscilloscope? It's the voltage. So let me grab one of those cursors. Let me grab cursor 1 for that. Cursor 1, Y1. Okay, so now I can scoot that little guy around. So note that when it's in the middle of the screen, it is at 0 volts. And then when I scoot it up, I can bring it up to wherever the green curve crosses our vertical, right? Because that's where I had tau. So now that's crossing right there. There's an extra cursor on there, and the reason that that's there is because doing it like this can be kind of finicky, like having, everything actually set to 0 and then just using one cursor. So what's easier is to just take the delta of the two cursors, right? Because then I can screw around with wherever these things are centered, right? Let's say they're down here, and I'm trying to figure all of this stuff out, and maybe it's scooted along in time or something, right? So to do this, the way that I would do this is I would go, I'm going to grab the first cursor for time, so x1, and I'm going to move it to the start, what we're going to call time 0. So let's say if I'm doing the discharge, maybe that's right here. Maybe this is time 0. You can see that x1 is like minus 600 something microseconds because 0 is somewhere over here, even though I shifted it over, right? And the cursors move with this when we shift the curve around, okay? So what should I do now to measure tau? I've set x1 to 0, so what do I do? I've set x1 to 0. I have a second cursor, x2. Okay, so x2, let me grab that one. Where's that guy? That guy's over here. So this one, now we're not looking at the value of x2, right? Because it's going to be shifted just like x1 is. Instead, just look at this guy right here, which is delta x. So this is saying the difference between the two cursors. See, when they're on top of each other, delta x is 0. And then if I move this out, that's the value I care about. Okay. So here's 100 microseconds. Similarly, where would I put my y1? So the top, right? Because right now we're measuring discharge. So the time 0 is basically the top, and then it's going to turn off. Let me scoot that guy up to right here. Cool. Again, this is going to give us a delta, so a difference between our two cursors. Oh wait, I just moved y2. My bad. Let me go back to y1. I don't think it matters which one you choose. You just have to mind the sign. Actually, not totally sure about that though. So y1 we wanted up at the top, as Jerry said, and then y2. This one, where does this one go if we're investigating what is the voltage at time tau? Nope. I guess that. Remember, if everybody wants to look here at what I got going on here, so I've set my vertical cursors right here to a distance, that's a distance of tau, right? And I've set my y1 to the top of the curve. So where should I put this cursor right here?
Where the green meets the X.
Yes, exactly, where the green meets the X. So that's gonna be right about, it crosses right there, right? This is the spot we're looking at, okay? And we check out, again, we don't look at the actual y value because we have y1 as some value, y2 as some value. Just look at the delta y's, the difference between our two cursors, since we set one at the baseline and then one at the time we're interested in. This is at minus 5.93 something, right? So that may or may not be good. We're not totally sure because we calculated for charging, whereas this is discharging. So I'm going to scoot everything over. And I can move x1. This is where it helps to have them linked. So y1, y2 linked, or no, I just want to move x1, x2 linked first. So let me scoot both of these guys over, all the way over to here. Cool. And then y1, y2, this is now measuring as we're charging. Cool. So it ends up being like this. You see the delta is the same in either case. Or the delta is the same. But you can see that since I have y1 on top, now it's a negative value. So I probably want to flip those around. Okay. Also, does somebody have the time? Just so I can. Almost 3, okay, cool. Believe it or not, we're still doing okay on time. This is about how long it took in the first section. Okay, so I'm swapping these spots and now my delta is positive. Cool. This is like 6 volts right on the dot. Is that reasonable or not reasonable based on our calculations earlier? It's reasonable, right? Because what was that? There was like 6.3 volts or something. All right, and then 2 tau was what, like 85? I think 8.6, something like that. So 2 tau is just, remember, it's integer multiples of tau, so 100 microseconds. So what would 2 tau be? If 1 tau is 100 microseconds, what is 2 tau? Yeah, 200 microseconds. So I'm going to grab my X cursor, my X2 cursor, scoot that guy over to where it says 200 microseconds on the delta X. Here we go. Cool. And then where do I put my Y2 cursor? On the green, but where on the green?
Where it crosses.
Where it crosses, yes, exactly. So the cursor goes right here where it crosses, and we get 8.25. That's pretty dang good, okay? It's gonna get harder and harder to measure as we get further out because this curve flattens and it's less well-defined where it is, right? But you can see that at 99%, we basically say that this is full. So the reason that we don't want a super short frequency, or I guess super high frequency, is the capacitor won't have time to charge up, so you won't be able to get all the taus you need. 1 tau, 2 tau, 3 tau, 4 tau, 5 tau. So I'd suggest picking a period of like 6 to 8 tau. Just go with 6 tau. We'll be fine. Yeah, and then so for the other part, that's our this is our low pass filter, or our integrator. For our high pass filter, the circuit stays almost exactly the same. Let me shut this guy off real quick. Disconnect these. This part will go much faster. So now we have the high side is connected to the capacitor leg, which is not shared. And then the low side is connected to the resistor leg, which is not shared. Okay, again, for measuring the signal, where does this clip go? Ground. So that's over here now. I'll just connect both my clips right now. So shaky. There we go. Okay, 1 clip, 2 clips. Connect 1 clip to another clip. There we go. Okay, and then for measuring the input signal, I can just put this at the red probe, or the red, so the supply, right? And then for measuring the voltage across now the resistor, right? Because they've swapped spots. So that'll be just on the other leg of the resistor, which is on this side of the capacitor. Let me connect that guy up. Okay, so this is probably going to be very hard to see, but I'll leave this circuit for a little bit for you to come around and look at in a second. But for now, I'll just leave it be. Okay, so when I turn this on now, you see not a whole lot happening, which may or may not be fine. We'll see. So let's recall that the amplitude normally is very low when we start it up. So let me bring this up. Okay, something's happening. Again, we're doing 5 volts peak to peak on here because in reality it's 10 volts peak to peak because of the weirdness with the 50 ohms. See that something's happening here. Why is it freaking out? The trigger. So just press it for 50%. Cool. Remember, if that doesn't work, that probably means that you're triggering on the wrong channel and you're only measuring 1 channel. Right, so it probably means that you have like your yellow probes plugged up, but that maybe it's triggering on channel 2. So when you press it, it's like, I don't know where 50% is, so it won't even try. Okay, so if I want to center these, if I want to center these vertically, what do? I can just press this, bam, press this, bam. Now they're centered, cool. Now for my coupling, I'm going to set this to DC coupling, okay? So for DC coupling, that will look like, click channel 1. Coupling is at DC, good. How about channel 2? coupling is also DC. Great. Let's apply our offset, and I want you to notice what happens here. When I apply my DC offset, notice how only one of the curves is moving. So here I've set it to 2.5, which in reality is 5. And so it scooted the green one up 5, which is my input signal, but my yellow one is still at 0, my output signal. Why is that? And also, if you can see the differentiator circuit is the bottom one there, or the high pass. Why is the DC offset not seen on the output? What do capacitors do? They block DC, right? So it doesn't matter what the DC offset is here, it's not going to care, right? Initially, when I did this earlier today, I was all thrown. I was like, wait, something's wrong. And I was like, oh, no, that's like the whole point of putting a capacitor in series. Okay, we want a square wave. So let's do that. And this is the characteristic curve you're going to see for this type of circuit, okay? So investigating what is going on here, again, you're doing the same thing with R and C. Tau stays the same, right? So you work with the cursors however you're going to work with them. You stop this, put in a USB stick, save the CSV data to that, all that good stuff. Let me see, what else do I need to say about this? Yeah, I guess just thinking about what's going on with this signal. Does anybody know like why that signal is the way that it is? Kind of weird looking. So here's what we can do. Let's go over to the whiteboard so everybody can go back to their seats for now. I'll leave this whole setup so you don't have to come see it right now. Just hang on for just a second.